Hello, and welcome to Algebra for Adults with Mr. Harris, where today we're going to do some training on how to graph a line. This training will include using the slope-intercept form. We're going to provide step-by-step and also complete explanations for everything we do. So let's get started. Slope-intercept form is y equals mx plus b. I hope you've seen that before, and I'm going to jump right into some terms. First of all, what's a graph? A graph is a picture of the answers to an equation. Remember, a picture is worth 1,000 words. What's a line? We're talking about a straight line. That's the shortest distance between 2 points. What's the Cartesian coordinate system? That's where we graphed it, where we have the x and y axes. We call that a plane of reference. The linear equation is just another name for an equation of a line. And when you get to the equation of a line, there's 3 different forms it can possibly come in. Slope-intercept, standard form, and point-slope form. We're going to take a look at all 3 of these because you need to be able to go back and forth between them in order to be good at this topic. Okay, now we're going to take a look at this graphic over here where we show you a line that crosses the y-axis. The name of the formula we're using is slope-intercept, so we need to make sure we look at what the slope is and also what intercept is. Starting with intercept, an intercept is where the line crosses the y-axis or whichever axis we're talking about. In this case it's y, and anytime any point has coordinates. The coordinates of this point right here where it crosses the y-axis is 0 for x and b for y. Whether it's 5, -10, 3, 7, it can be any number. But this point of intersection, we need to know that in order to use this formula. The next thing we need to know in order to use this formula is the slope. What is the slope? The slope is a measurement of the change in the y variable, how much we go up, over the change in how much we go over the x variable. So we'll look into that later on. But if we know that, then we can just plug it into the formula y equals mx plus b and begin graphing. Now when it comes to graphing, we have a 4-step method. We want to end up with y equals mx plus b, but we don't always start out with y equals mx plus b unless they want you to graph, and very seldom do they ask you to just graph. So what we're going to do here is we're going to look at why we want y equals mx plus b, because it gives you a quick way to graph the equation. Number 2, so here's the 4-step method. Step number 1, write the equation in slope-intercept form by solving for y, just in case it's not solved for y. Number 2, find the y-intercept. That's the b down here, whatever that is after you've solved it for y. We're going to use that to do our graph. Step 3 is find the slope. If we already have the equation solved for y, the slope is just the number in front of the x variable. And we're going to use that number and our definition of slope to graph the equation, to find another point on the line in particular. And then when we find that second point, we're going to draw a line through the points. Now remember, step 1 says write the equation and slope-intercept form by solving for y. So we're going to do this equation right here. Why? Because this is the type of equation they're going to give you, something where it's not solved for y. You have to show some algebra. So right here, we're going to use this, and starting with this, we're going to go to step 1, which is solving for y. Now here's some math to solve for y. In case you don't know how, you can go over this on your own. But you should end up with this right here. When you have y isolated by itself, y is going to be equal to 3/4 x minus 2. Y is equal to mx plus b. So let's graph this here. The first thing we're going to do, we're going to get out our coordinate plane right here, x and y. This is 0, 0. And what was step 1? Step 1 was solve for y. So we've already done that there. Solve for y, slope-intercept form. Step 2 was plot the intercept. That's the b. So we know the b is -2. So right here, -2. Step 3 is to use the slope. The slope in this case is 3/4. Rise is 3. The run is 4. So that means over 4 up 3. When we plot that, we're going to get 4, 1. Now, and finally, the last step is just draw the line between the 2 points. Now, what could be easier than that? Hey, you can graph. Next, we're going to look at special cases of graphing when y is equal to 3 and x is equal to -2. This is not y equals mx plus b or anything we've seen before. So when y is equal to 3, that's going to give you a horizontal line. Horizontal, that means going across. So you notice right here in the red, there's your horizontal line. Every point on that line has a y coordinate of 3. The x coordinate is going to be different for every point. Finally, when we have x equals -2, that's going to give you a vertical line. Okay, that's coming down. Notice that every point on this line has an x coordinate of -2. So please try to remember this here when you see those. Man, this is so easy now. Hopefully that's what you're saying. Because right now we're going to go into a little more challenging part where we're going to look at converting point-slope formula of a line to a slope-intercept formula. Now this is often the type of problem given, so we're going to look at that. If you've never, a lot of students don't have a lot of experience with point-slope. Point-slope is y minus y1 equals m times x minus x1. The y and the 1 and the x1, that refers to the point in the formula, in the name. And here's our familiar m, which is a slope. And we're going to convert this to y equals mx plus b. There's a lot of ways to do this here. I'm going to present one that gives you a lot more instruction. So, for instance, suppose we have these points here, 1, -2, and they're on the same line. They might want you to find the point-slope equation for that line. So to find point-slope, all we have to do is remember this is the equation. We already have a point. Matter of fact, we have 2 points. So that means I can actually come up with 2 different equations. And then we're going to substitute the point into this along with the slope. So with these 2 points here, the first thing we need to do is figure out the slope. I've given you 2 ways to figure out the slope. One is using rise over run, just quick graph, and you can figure this out. The other one is where you actually do algebra over here and you calculate the slope. So you can take a look at those on your own time there, but you should come up with a slope of 2, which is really a slope of 2 over 1. So 2 over 1 is the way we want to use it in the formula. Now, after you get the slope, which we said was 2, we can plug either point into the point-slope formula and use them. So I'm going to do point 1 first. Y minus 6 equals 2 times x minus 5. Make sure you understand that. And here's the other point. I'm going to put y minus a minus 2. Please remember that this was a -2 and there's a minus in the formula. So a minus and a minus, that's going to give you a plus. So you're going to end up with this here. This here, these are your point-slope equations of the line. Now if we want to graph it, we have to convert that to y equals mx plus b. So in this case here, I did both of these. This is this is the first equation. Okay, where I solved that for y. So make sure you can understand how to do that. Here's the second equation. I solved that for y. You don't have to do both of these, but I'm just trying to show you, if you understand this, you know that both of these answers are going to give you the same equation for when you get to slope-intercept form. Okay? And then finally, we're going to graph it. How do we graph it? The same way we did before. Here's our equation that we ended up with. Y equals mx plus b. We're going to go to the -4, put that on the paper. Then we're going to use the slope, which we said was 2 over 1. So we're going to go over 2. Over 1 and up 2. And we're going to end up with a point at 1, -2, and then we just draw a line connecting those points.